Why doesn't the hydrogen electron stick to the proton due to the attractive force of the proton? I think the current standard model of particle physics and quantum mechanics are unreasonable. If we create a new model, we can make particle physics and quantum mechanics simpler, right? So, the first thing I thought of was that quarks don't exist. When it was discovered that neutrons are protons and electrons bound together, the existence of quarks should have become unnecessary. Therefore, the existence of gluons to bind quarks together is also unnecessary. The second theory is that protons are made up of positrons and neutrinos. This is an association from the pp chain reaction. It is thought that a huge number of neutrinos are densely attached to the positron and around it, forming a thick layer. The reason why neutrinos stick to positrons but not to electrons is thought to be because neutrinos have a very weak negative charge. This would explain why hydrogen electrons can exist at a certain distance around protons. First, the electron is attracted to the positive charge of the positron at the center of the proton, but when it gets too close, the repulsive force of the negative charge of the layer of neutrinos clinging to the positron becomes stronger, and it is unable to come into contact with the proton. Also, when the electron tries to move away from the proton, at a certain point the attractive force of the positron becomes stronger than the repulsive force of the neutrino layer, and it is bound. As for the mass of the proton, it is much larger than the mass of the positron. If we consider what the difference is, it is due to the layer of neutrinos clinging to the positron, and most of the mass of the proton is thought to be due to the mass of the neutrino layer. The mass of a single neutrino is very small, but if there are an enormous number of them, it is thought that they can reach that mass. Why are neutrons heavier than expected? Neutrons are protons bound to electrons, but their mass is said to be more than simply a proton plus an electron. Is it because of the anti-electron neutrinos said to be emitted during beta decay? I thought that if the electrons penetrated into the neutrino layer, the attraction between them and the positron would be stronger, and conversely the repulsion they receive from the neutrino layer would be weaker and they would stabilize as neutrons. Maybe the anti-electron neutrinos are attached to the electrons that are stuck in the proton. If so, the anti-electron neutrino may also have a very small positive charge. It is also conceivable that the pions are thin layers of anti-electron neutrinos attached to the electrons.